This is determination of an aerodynamic center of a supersonic missile. In this lab, you will use the supersonic wind tunnel as well as the data acquisition system to find where the aerodynamic center of a missile is located. The aerodynamic center is defined as the place where the moment does not change with angle of attack. You will also be finding the Mach number of the flow analytically. Before we get started in this lab today, we need to make sure that we're always practicing our 4 pieces of safety in this lab. First and foremost, make sure that you're always wearing your hearing protection. Next, make sure that the door is closed before you start any experiments. While dealing with the equipment itself, you always want to maintain that the test section is locked into place and that you blow the horn 3 times before you start the flow of air. In this experiment, we used LabVIEW to record all the aerodynamic forces seen by the missile in the test section. To open LabVIEW, we go to the Supersonic Wind Tunnel Data Acquisition, labeled SSWT-DAQ. Once you've opened the program, it's going to prompt you for a username and password. The username is AeroLab, and the password is SSWT, standing for Supersonic Wind Tunnel. Once that is complete, it will prompt you to choose a file to save to, and we're going to use Test 2010. The first thing you want to do, maintaining that there are no external forces on the missile, is hit Tear. With the program now reading 0 at all the different forces, we can move on to finding where our moments are measured from. The first thing you're going to want to do with the missile is take all the measurements given in the lab manual. Once that's complete, you're going to want to use a straight small edge to try to find the location of where the pitching moment is being measured. In order to do this, you're going to press down slightly with the straight edge on the missile at different locations. Someone over on the data acquisition system will be looking for where there is a 0 measurement of force on the pitching moment. This is because if we push down in front of where the measurement is being taken, there will be a negative value registered. However, if we push on behind where the measurement is being taken, there will be a positive measurement taken. This means that if we push down and there is a 0 force registered, that means we have found the location where the pitching moment is being seen. Before we get started, we need to make sure that the wheel is turned all the way out on the safety valve. This makes sure that we actually have flow coming into the building. In order to maintain this, you want to make sure that the screw is all the way out. The next thing you're going to want to do is flip the switch on the control box to on for the lights to light up. Then you can get started actually preparing the experiment. There are a few more things that need to be completed before we can actually start the test. First of which is making sure that we are at the correct angle of attack. Right now we're at 9 degrees angle of attack, which is actually 6 degrees, since the 0 angle of attack number is 3 degrees. The next thing we need to do is make sure that our counter reading is correct. Our counter reading controls the Mach number of the test section itself by changing the area of the test section. A graph that can be found inside the lab gives you the counter number that will correlate to the correct Mach number. In order to switch this, you will push the either Mach up or down buttons on the control panel, which will move the counter number itself. The last thing you want to maintain is someone is always watching the stagnation pressure and another person is always watching the test section pressure. Both of these will fluctuate a little bit during the test, and so you want one person per gauge to make sure that you're getting the correct values. Once you've recorded these values, you will also be able to find the Mach number analytically through this. The last thing that needs to be done before actually starting the experiment is some sort of hand signal needs to be worked out between the person running the tunnel and the person running the computer. This is to maintain that you know when to take your measurement even though you're wearing your hearing protection. Once that is done, the person running the tunnel can flip the switch to on, which has been off so there have been no accidental firings of the test section, and then blow the horn 3 times and start the tunnel. You will hold the button down for the duration of the test. Once the tunnel is started, the person running the computer will wait at least 1 second so that the flow can stabilize in the test section, and then grab the data. Once that's complete, they'll give a thumbs up again, and the person can release the button, ending the flow through the chamber. The most important thing for the person running the computer to remember is to always make sure that they have the same angle of attack reading that is actually seen by the test section. So in this case, we have a 6 angle of attack, and we are ready to go. Once the test section has been running for at least 1 second and the flow has stabilized, you can hit the grab button and the data points will be taken. You will continue to do this exercise through the range of angles of attack given by the lab manual. And once you are completed, you can copy and paste all these numbers into Notepad and get them off the computer using a flash drive. Then you can start your data reduction for this experiment. Make sure that everything is turned off and all valves are closed before leaving the test